first function prime 2 plus first function times the second one prime plus x prime, which is 1. So the answer here is 2 natural log x plus 3. Can the second derivative be 0 or undefined? It's undefined at 0, but so is the function. Good. So then 2 natural log x equals negative 3. And natural log x equals negative 3 over 2. And remember, I have to change it into an exponential equation to solve it. How do I change it? Anyone would like to help? How do I change this into an exponential equation?
E to the power of negative 3/2 equals x.
Excellent. So I put in e, and in parentheses, negative 1.5. That's what this is. And I get, no, yes. Okay, got it. So x is approximately 0.22. Yes, of course. Of course it's 0.22. So that I can mess up the entire graph, the entire table. Okay. I need to study the sign. When I plug in 1, this is 0, so the whole thing is positive. So the function opens up. But in the second derivative, I also have to plug in something like why did I write minus? Nobody knows. Of course it's a positive number. Of course, it's e to something. Good. So at 0.22 it's 0, but I also have to plug in the second derivative 0.1 to see if this is negative. So here's the second derivative. So 2 times natural log of 0.1 and plus 3. This should be a negative number, and it is negative 1.6. I don't care about the number, I only care about the sign. And also, 0.22, I have to plug it in the function. Because I need to determine the y value for 0.22, like I did for 0.61, like I did for 1, of course. So I have the function. That's why I put in the function. And now I'm going to plug in 0.22. So it's negative 0.073. My goodness. 0.073. With 0.61, it's negative 0.2. And with 0.22, I'm looking again. Yep. With 0.22 was, yep. Okay. So now, what type of point is 0.22, comma, negative 0.073? What type of point is 0.22, comma, negative 0.073?
Isn't that a relative max?
Careful.
No, min.
Careful. When we talk about the second derivative, we can only talk about inflection points. When we talk about the first derivative, we can only talk about max min. So once we finished, it's a very good question. Once we finish the study of the first derivative, we can no longer talk about max min. When we go to the second derivative, we can only talk about concavity and inflection point or inflection points. So this point is an IP. I will present my table one more time. I don't like it because it's so squeezed in there and it's difficult to read. So allow me to just quickly copy the table for everyone to see clearly what's happening here. Because the numbers are so close. So I have here 0, nothing, I cannot put anything under 0. I have infinity. I have 0.22, I have 0.61, I have 1. At 0.61, negative 0.2. At 0.22, negative 0.073. And we have 0 here, negative and positive, which is a relative min. And this is the IP, because the second derivative is 0. It's negative here, and it's positive here. So now this is easier to understand. There were two numbers very close in between to each other, in between 0 and 1. I had to leave more space or have more room in there, so it's clear now. So this point goes with 0.22. I mean, 0.22 comma this is the inflection point because the second derivative is 0 at this point and changes concavity. 0.61 comma negative 0.2 is a relative minimum because the first derivative is 0 and it changes sign this way. Any questions? So this limit could possibly be 0. We'll see. I will not forget to come back to this when we get to 4.4, I promise. How do you feel about the table now?
I feel good.
Very good. Do we need other examples? Do we want to look at other examples? With pleasure. If you need more, let's do more.
One more maybe?
Yes, of course. Some of them are intense. Some of them are a little bit easier. It depends on the function. We will have to choose a gibberish. That's our next item on the list. So we have to get there. So let's see if we want to look at other functions. I will pick 22. I guess it was my turn. So f of x equals e to the x over e to the x plus 2. So we're asked everything. Since I'm asked everything, without the graph, not yet. We're going to graph. But we're going to start with easier, simpler situations. So we have f prime. We have f of x. And we have the second derivative. First, I have to start with the domain. Can anyone give us a domain of this function? So I have to put it here and then move on to x and y intercepts and asymptote limits. It's a rational function combined with exponential. What would you worry about for this function? What can go wrong? What could go wrong? Anyone? Please try. Please participate, please. I'm kindly asking you, please.
With the domain,
Yes. So
uh,
so yeah. So it's only e to the x plus 2 if it's 0. There is nothing else. E to the x is a positive number always. E to the x is a positive number always. E to the x plus 2. Can it be 0? Can a positive number always plus another positive number always, can that be 0? No. So there are no restrictions. That's never 0. So the function is defined everywhere. Good. So I have to plug in 0. When we plug in 0, e to 0 is
1.
1. So 1 over 1 plus 2. Now this is the y-intercept, but can this function ever be 0? No, because this is always a positive number. So there is no x-intercept, but there is a y-intercept. When x is 0, y is 1/3. So the only thing that I need to find are these limits, and we're done. We move on to the first derivative. So limit Sx approaches negative infinity from e to the x over e to the x plus 2. If you remember with limits, we have to plug it in first. So let's plug it in. Where is the numerator going when x approaches negative infinity?
It's going to 0.
Exactly. And here's how we know. Because e to I shouldn't write this, but I want to write it. 1 over e to infinity. So e to negative infinity is 1 over e to infinity, which has to approach 0. No question about it. 1 divided by huge, this will always approach 0. Excellent. So then we know that this approaches 0, and we know that this approaches 0. So then what is the answer?
0.
Yes. So when x approaches negative infinity, the y values approach 0, which means y equals 0 is a horizontal asymptote. Now, at the other end, limit as x approaches infinity from e to the x over e to the x plus 2. This is infinity over infinity. What do you recommend we should do? We had similar examples, or at least one. What did we do with this? Here is your hint. We factor out e to the x. What is left in parentheses? I need two terms.
1 and 2 over e to the x.
Perfect. Of course I'm going to simplify. Anyone can tell us where is this going when x approaches infinity?
Going to 0.
Excellent. So then how much is 1 over 1?
1.
Excellent. So this is 1, which means y equals 1 is a horizontal asymptote. At this end, this one is at this end. Okay, there is nothing else we can find about the function from the function itself. The limits and x and y intercepts, if they exist. Now we move on to the first derivative. And we will study the first derivative with critical numbers and the sign, etc., etc. Stop me if you have questions. Any questions so far? Anyone? Okay. So I'm going to copy f of x, which is e to the x over e to the x plus 2. And I will find the first derivative. Okay, what rule applies here?
quotient.
Yes, e to the x plus 2, everything squared first. The top function prime is e to the x times the denominator. and watch me run out of room, minus the numerator times the denominator prime, which is the same thing, so I'm going to write it squared because I'm running out of room. And the 5 is the page number. It's not connected to what I'm writing here. So I will distribute e to the x, copy the base and add the exponents. E to the x times e to the x, copy the base, add the exponents, plus 2e to the x minus e to 2 times x. I'm super happy. So the answer is 2e to x over e to the x plus 2, everything squared. At this point, we're asking ourselves, because this is the first derivative, does this equal 0 or undefined? No, this is always defined. When is a fraction 0?
When the numerator is 0.
Good. 2e to the x is 0. Can e to the x be 0? Let's look at the graph. This is the graph of e to the x. Please remember it. Can e to the x be ever 0? No. Very good. So it's always positive. None. Okay, what is the sign of all this then? Because I need to put it in here. I couldn't find any critical numbers. Obviously, the function doesn't have a max min, but I have to find the sign of the derivative. Can anyone tell us what is the sign of this derivative?
Positive.
Always positive. 2 is positive, e to the x is always positive, the denominator is always positive, and it's even squared. Awesome. So therefore, at this point, I need to make sure that this row goes in sync with this one. If it doesn't, there is an error somewhere. That's how I catch my mistakes. Okay. From 0 to 1/3, what does the function do?
Can you repeat that?
Yes, from 0 to 1/3, what does the function do?
Increase.
Yes, and it's supported by the sign of the derivative. From 1/3 to 1, what does the function do? From 1/3 to 1.
Increase.
Good, and it's also supported by the sign of the derivative. Now we want to, so now if I ask, where is this function increasing? What will you say?
The entire domain.
Exactly. That's it.